Good morning. Today's shout out before we start will go to Tyler for officially winning the stock market game this year. It wasn't just about the lunch, but he actually was part of the winning team. Congratulations. Today's goal is that you can solve a quadratic using the quadratic formula. Of all the methods that we've used to solve quadratic so far, we've talked about graphing, how it's not always feasible to do and it's not always accurate because your graphs aren't always accurate. Then we talked about using square roots, which don't always work. Then we talked about factoring, that does not always work, but when it works it's nice and easy. Quadratic formula is one method that will always work no matter what type of quadratic that you have. So let's get started. So to solve using the quadratic formula, the most important thing is that your quadratic be in standard form. It needs to be in standard form, which is ax squared plus bx plus c. It has to be in that form so that you can figure out what your a is, what your b is, and what your c is, because you're going to use those numbers in the formula. So your main goal today would be to memorize the quadratic formula and make sure that you have it committed to memory. There is a song that you're going to play after you watch this video that will help you to memorize it, which is how most kids memorize the quadratic formula. But the quadratic formula is, I'm writing this color-coded, you'll see why in a second. Alright, so the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. You use the a, the b, and the c from your standard form quadratic. I color-coded it, so hopefully you will recognize that part of this you should have already had memorized, which is our axis of symmetry, which is negative b over 2a. What's inside the square root has a special name. In math, we call that the discriminant. And you always want to do this part of the quadratic formula first. So we always solve for the discriminant first. And the reason why we do that is because if inside the square root ends up being a negative number, you can stop. Because if that's a negative, we're going to write no real solution as our answer because we're not going to be doing the square root of a negative number. So the discriminant is b squared minus 4ac. If you do that and you get a negative number, that means there's no real solutions. If you do that and you get 0, so b squared minus 4ac and you get 0, that means there's exactly one solution to that quadratic. And it would be a situation where the quadratic just touched down on the x-axis at one point. This would be a situation where the quadratic never touched down. The reason why you would only have one solution is because the square root of 0 is 0. And if you do negative b plus 0 and negative b minus 0, you get the same exact answer. And then if your discriminant is positive, that's when you have two real solutions, and that just means that the quadratic crossed the x-axis in two different locations. So you'll memorize this formula using the song, Goes to Pop Goes the Weasel. When you're solving, you need to make sure it's in standard form so you get the correct a, b, and c. And you always do your discriminant first, because if you get a negative discriminant, that means you can stop and you don't have to plug in the rest of the numbers. That means there's no real solution. So then once you do plug in, you're going to get some weird looking answers sometimes. So you need to make sure that you can simplify answers that come out like this. You might have a situation where you get 12 minus square root 50 over 6, and you need to know how to simplify that. So sometimes you're asked to get a decimal, and you would use a calculator for that piece of it. But sometimes you're asked to just leave it in simplified radical form because that makes it a more exact answer. So to do that, if you have this situation, you want to simplify your radical. And I know that the square root of 54 will break down into 3 root 6 because the square root of 9 is 3. So if I rewrite this, 12 minus 3 root 6 over 6. My next step to see if I can simplify this anymore is to look at this triangle of numbers. If that triangle of numbers can all be divided by the same number, then you can reduce this further by dividing by that number. So if I have a 12, a 3, and a 6, I can divide all of those by 3. So my final simplified version of this would be 4 minus root 6 over 2. I've divided 12 by 3, 3 by 3, and gotten 1. And I don't need to write 1 because 1 root 6 and root 6 is the same thing. And I'm doing 6 divided by 3. This would be final simplified radical form. You cannot divide these two because you need that triangle of numbers to be divisible by the same thing. For the next one, I start by simplifying my radical, and I know that 32 is the same thing as 16 times 2. The square root of 16 is 4. So this would be 4 root 2. So I would have 8 minus 4 root 2 over 4. Now I look at my triangle of numbers. My triangle of numbers is the number in front of the radical, the number in front, and my denominator. They can all be divided by 4. If I divide them all by 4, I'm going to get 2 minus root 2 over 1. Now I don't need to write this over 1 because the less symbols you use, the better. So you would get 2 minus root 2. So now we're going to try solving 2 quadratics using the quadratic formula, and then there'll be more for you to practice on the form and tomorrow and on Flipgrid. So for the first one, this is not in standard form, so I need to rewrite it so it's in standard form. So I will have 5x squared. I'm going to bring the 4x over to the other side as negative 4x minus 3 equals 0. So this is my quadratic in standard form. I now, once I have it in standard form, can figure out that my a is 5, my b equals negative 4, and my c equals negative 3. So now I'm going to do negative b, which would be the opposite of b, would be 4, plus or minus the square root of b squared. Negative 4 squared would be 16, minus 4 times a times c, all over 2a's, which would give me 10. So for the math part, I'm going to do this part first. This would be 20 times negative 3 would be negative 60. Negative 60 would be plus 60, so I would have 76 inside my square root. Now, this would be my radical answer, but it's not simplified, so I need to simplify all of this. So I'm going to do simplify 76. And I would get 2 root 19. So this becomes 2 root 19. Now I want to look and see if I can simplify this further by looking at my triangle of numbers. My triangle of numbers is the 4, the 2, and the 10. They can all be divided by 2. So my simplified radical answer would be 2 plus or minus root 19 over 5. I divided this by 2. this by 2 and got 1, but I don't need to write the 1. And this by 2 and got 5. Now if I change that to a decimal, so this is the most exact answer. And it does represent two answers because it says 2 plus this and then 2 minus this. So this represents the two roots. If I change it to a decimal, I would get approximately negative 0.47 and approximately 1.27. Those would be my two radical answers. Now for my second one, I'm just going to erase this work so that we have some space. For the second one, it's already in standard form. So my A in this case is 1. My B is negative 12. And my C equals negative 14. So the quadratic formula is negative B, so that would be 12, plus or minus the square root of B squared, should be 144, minus 4 times A times C, all over 2A, and 2 times A would be 2. So now we have 144 minus 4 times negative 14, which would be negative 56. And so we get square root of 200. Now I'm going to simplify this into 10 root 2. Now I'm looking at my triangle of numbers to see if I could simplify this further. All three of these numbers are divisible by 2. So I'm going to get 6 plus or minus 5 root 2 all over 1, because 2 divided by 2 is 1, so I'm not going to write that. So this would be the simplified radical answer. And then if I changed it to a decimal answer, I would get approximately negative 1.07 and approximately 13.07. So you want to make sure you can get the decimal numbers with the calculator as well. So now there's going to be a few for you to try, and then there's more on Flipgrid. Have a nice day.